Most AI coding tools are great at generating snippets, but they often fail when building real features because they lack the right context about your code base. This is where context engineering changes everything. Instead of throwing random prompts, you plan features with full clarity, and your AI coding agents can finally deliver production-quality results. Hello and welcome back to another video. Today we're going to see how Context Engineer MCP works inside Cursor to help you plan features with clarity and get production-quality results. This is where context engineering changes everything. Instead of throwing random prompts, you plan features with full clarity, and your AI coding agents can finally deliver production-quality results. We're using the Context Engineer MCP server inside Cursor. All you do is ask it to plan your next feature. It automatically analyzes your codebase and then asks you the right follow-up questions, not just high-level PRD questions, but also technical implementation details and design choices. This avoids the usual confusion where AI generates something that doesn't fit your architecture or coding patterns. Setup is quite easy. Before we jump into the setup, here's the final output: a complete checkout flow, cart, address, payment, review, confirmation, all working smoothly. Normally, this would take days to plan and implement, but with Context Engineer MCP, it only took me a couple of prompts. That's the power of giving AI the right context. First, sign in to the Context Engineering site and generate your license key. Once you have it, you'll see configuration options for different tools: Cursor, Claude Code, and Windsurf. In this demo, we'll be using Cursor. Simply copy the configuration for Cursor, open your MCP settings inside Cursor, and paste it in. That's it. Context Engineer MCP will be active immediately. You'll notice a planned feature tool. This tool is automatically triggered whenever you ask Cursor to plan something. Before we jump into the demo, let's talk about why context matters so much when working with AI coding agents. The hardest part isn't writing the code, it's making sure the agent really understands what you're asking for. If your request is vague, or the AI doesn't fully get your codebase, things break down. The PRD misses details, the technical plan skips dependencies, and the implementation gets messy. It's not just about writing better prompts. Even with a clear feature request, the agent still needs to know your architecture, your coding patterns, your libraries, your design style. When the context is right, planning is sharper, the blueprint is reliable, and implementation flows naturally. You spend less time debugging and more time shipping features that actually fit your stack. For this demo, I'm adding a full checkout flow to a React e-commerce project. This feature has multiple steps: cart, address, payment, review, confirmation, so it's the perfect case to see how planning works. I simply start with a prompt. Plan and implement a complete checkout flow with step navigation, form validation, and proper state management. The MCP immediately starts asking context-aware questions. What components should we create for each step of the checkout? Should we reuse existing transition styles to match the rest of the app? Which routing library do we prefer for step navigation? Do we need local storage persistence for partially completed checkouts? How should we handle data management across steps? Are there any third-party integrations we should plan for now rather than later? Answering these ensures the generated plan matches our real stack. No rework, no guesswork. Once I'm done answering, the MCP produces a structured planning folder with 3 files. The PRD includes the problem statement, core requirements, both functional and non-functional, user stories with acceptance criteria, technical considerations, and even success metrics. This sets a solid foundation for what we are building and why. The technical blueprint provides diagrams showing the current versus target system architecture, detailed data flow, both front-end and back-end components, required endpoints, database schema, and other critical implementation details. It's the high-level design that guides every code change. Since these are markdown files, let's open them in GitHub to preview the Mermaid diagrams. Here you can actually see the system visually, the current state, the target state, and the data flow connecting them. This is important because no developer ever has the full architecture in their head at once. By making it explicit, the AI agent works just like a real dev team. It knows where you are, where you need to go, and how to bridge the gap. Nothing extra, nothing missing. The task list clearly maps out each step, referencing which files need to be updated or created. You can mark tasks as complete or even open them in separate cursor chats to keep your progress organized. Now that everything is crystal clear, I can simply prompt Cursor to implement all tasks at once. Because the requirements, design, and tasks are well defined, the AI writes production quality code with fewer mistakes, saving you from endless bug fix prompts. If you want to track progress, you can mark completed items in the tasks file or even split them into separate chats to keep your history clean. Now let's take a look at what we've built. The AI has generated a complete multi-step checkout flow with clear navigation, from cart to address, to payment, to review, to confirmation. Each step has its own component logic wired together through context providers, exactly as planned in the technical blueprint. The forms have validation and smooth micro-interactions. Moving from one step to the next feels seamless. No broken state, no unexpected reloads. We hit a small form error during testing, but since the technical design was already in place, it was fixed with a single prompt. The result is a production-ready checkout flow, built consistently without messy rework and with code you can trust. So that's the Context Engineer MCP. It helps you give your AI coding agents the right context before they ever touch your code. With clear requirements, technical blueprints, and actionable tasks, you spend less time debugging and more time shipping features that fit your architecture perfectly. If you found this helpful and want more content on AI-powered coding workflows, make sure to subscribe to the channel.